Hello everyone. In this video I'm going to show you how to solve word problems using a system of inequalities. As you watch the video, I would like you to do the following. You are encouraged to pause and rewind the video as much as you'd like to, while also taking notes on what you see. I also encourage you to try the problems in the video before you watch the solution that I give you, and then write down any questions you have remaining after you've watched. Before we get into how to solve a system of inequalities word problem, I'd like you to do a quick warm-up question. I want you to take the words that are in the box there and try to match them with the two inequalities that you see below. So pause the video, try to match them, and then press play when you're done. Okay, let's see how you did. So the first inequality is x is less than or equal to 2, which if you think about it, that means that the value of x cannot go above 2. So the phrase at most actually goes with that inequality because you don't want to go above 2. Another one that goes with that, the same thing as at most, is maximum. So we'll move that there as well. And then we have is no more than and is no less than. We can't go above 2, so is no more than actually goes with that inequality. The other three then go with x is greater than or equal to 4. In that second inequality, if x is greater than or equal to 4, that means that the value of x can be 4 or anything above that. So that means a minimum of 4. It could also mean at least 4, which is anything above 4. Like if I say I need at least 4 of something, I could have 5, it could have 6, it could be more than that. And is no less than also goes with that, because you can't go less than 4, it's everything 4 and up. So knowing those terms is going to be very important to solving these problems, because you're going to be reading word problems and you have to know which symbol goes with the words that you see. So I'd like you to copy the following chart into your notes. It's inequality vocabulary. So pause the video, take a minute, and copy down this chart. Okay, so I hope you're familiarizing yourself with this vocabulary because you're going to be seeing it in the problem that I show you here. So let's look at a word problem that involves a system of inequalities. Here's the question. After losing his last job, Gino has recently started babysitting and tutoring to earn extra cash. His babysitting job pays $3 per hour, and his tutoring job pays $6. That should be per hour. Because of school, Gino's parents only allow him to work a maximum of 15 hours per week. How many hours can Gino tutor and babysit and still make at least $66 per week? So in order to answer this question, we actually first we'll want to model it using a system of inequalities. And I know that I'm working with an inequality problem here because I see a lot of keywords here. Let's see if you guys can identify the keywords. When I'm reading this, I see the word maximum, all right, which tells me that he can't work above 15 hours. He could work up to 15 hours. I also see that he wants to make at least $66. Which means he could make $66 or more. So those words tell me that I'm working with inequalities. Now that I've identified that, I can create a system of inequalities to model the situation. The two things I don't know in the problem are the amount of hours that he works babysitting and the amount of hours he works tutoring. So what we're going to do is create variables for those things. Alright, so let me scroll down to give myself some room. And since we're dealing with a word problem, we have to define variables here. So I'm going to let's let x equal the number of hours babysitting excuse my handwriting, I'm using my iPad. And let's let y equal the number of hours tutoring. Okay, so now we've created that. Now we can create the inequalities out of that. So we know a couple things. He can work a maximum of 15 hours. So that means if you combine x and y, the most he can work is 15. So remember, we talked about the word maximum goes with less than or equal to. So that's one inequality. X plus y is less than or equal to 15. The next thing we know is that he needs to make at least $66. He makes $3 per hour babysitting and $6 per hour tutoring. So remember our money problems. If we multiply the number of hours by how much he's earning and combine those things, and he wants to make at least 66, so that's greater than or equal to, here's our system of inequalities. So now I have to create the graph of that. And if you look at my axis that's already partially created, I already kind of have the values labeled. I just have to now create my titles and make sure that my lines are graphed correctly. So let's start with x plus y is less than or equal to 15. And let's label our axes. So let's let the x-axis, since I defined x as the number of hours babysitting, call x the number of hours babysitting. Make sure you label your axes. And let's also title the graph. Let's title it Gino's Jobs. My handwriting is atrocious right now, I know. Gino's Jobs. And let's let the y-axis be hours tutoring. Wow. Poor handwriting. Okay. Number of hours tutoring. Good. Alright, so you're also going to have to excuse me here because I'm using the iPad, so it might be tough for me to draw lines, but we'll see how I do. Alright, so let's start with x plus y is less than or equal to 15. If I were to take that inequality and rewrite it so that it was solved for y, that would actually help a lot. So I could take x plus y is less than or equal to 15 and rewrite it as y is less than or equal to negative 1x plus 15. So to graph that, I'm going to start at 15 on my y-axis, and the slope is down 1, right 1. I have to look at my units carefully. I also didn't label 0 here, so you should do that too. That's 0 hours. Alright, so if it goes down 1, right 1, that means that the line will look like this. My slope is negative 1. So I've done that. And I could continue, but since I have a bunch of points, I could just use a straight edge to create the line. Remember, with inequalities, you have to consider if it will be a solid line or a dotted line. In this case, since it's less than or equal to, I can use a solid line to connect these points. Very good. I don't need arrows because I'm not going to go below 0 on either of the hours. But now I have to shade which direction that the points that make it true will be. And since it's less than, I'm going to shade the lower portion of this line. Okay. So my inequality for x plus y is less than or equal to 15 looks like that. Now I have to create the graph for the second part, which is 3x plus 6y is less than or equal to, or I'm sorry, greater than or equal to 66. I have to do the same thing I did with the last one, which is to solve for y. And if I do that, I'm going to y is greater than or equal to, and nothing's going to change there, but it's going to be negative 1/2 x plus 11 if you've solved it correctly. Okay, so I'm going to graph that line now. Again, it's going to be a solid line because it has the equal to bar, but then I'm going to shade up. So let's graph the line. It starts at 11, which is right there. And my slope for this line is down 1, right 2. So I'm going to go down 1 on my y and right 2 on my x. And that's my next point. I'll do it a couple more times so that I make sure that it's right. Okay, so now that I've done that, I can use my straight edge to connect. Again, it's a solid line. So that's how I connect. Alright, and I'm going to shade up because it's a greater than inequality. Okay, so I've graphed both inequalities, and now I have to answer part B of the question, which is to state one possible solution. Remember, with a system of inequalities, anywhere in the shaded region, where the shaded regions intersect, anywhere in there, which is this part here that I'm coloring in pink, can be considered a solution to the problem. So if I look at my, let's just make an example. If I look at my number of hours babysitting, I can go to 2 and match that up with, let's say, 13 hours tutoring. So I can make one possible solution be, and I'll just write it over here in the green section. My answer could be 2, 13. But let's talk about what that means. That means that Gino can tutor for let's reverse it. He can babysit for 2 hours and tutor for 13 hours. And let's see if that all makes sense. The limits are that he can work at most 15 hours. If you add those 2 hours, it's 15 hours. And he needs to make at least $66. So if I multiply 2 by 3, I get 6. And 6 by 13, I get 78. So if you add those two, you actually get more than $66. So it's perfect. That's all you had to do here. Once I graphed it, I was able to use my data to find one possible solution. So to summarize what we talked about here, you have to create the inequalities based on the unknowns, you graph them, and then make sure you answer the question. So that's how you solve a word problem using a system of inequalities. Find the keywords, and if you see those keywords, you use them to create the inequalities, you graph them, and then make sure you answer the question. So now that you've seen all of that, what I want you to do is go to the class website and fill out the Google form, and then, of course, watch the video as many times as you want. I hope you've enjoyed watching.